Hey guys, and welcome back. Today we're going to be talking about initial value. Let's take a look at the learning target. It says we're going to compare rates of change in initial values and interpret their meanings in context. So this is the same learning target that we've had for the past couple days, and I just want to highlight in that learning target that initial value portion. You've been seeing that we're going to be talking about initial values, and this is the lesson that actually entitles what we're learning, initial value. So in order to be successful today, you're going to be able to identify the slope and rate of change from a graph or equation. That is not new. Okay, so this one right here, this is not news, but we're going to refresh your memory on it. We're also going to identify the y-intercept from a graph or equation. In fact, y-intercept is something we're going to connect to the initial value. So let's take a look at the key idea here. Again, I've given you guys our form, y equals mx plus b. Remember, m is the rate of change. Okay, I have that labeled right here. And then the b is the initial value. Yesterday, we were calling that the y-intercept, or not yesterday, on Tuesday. This is the y-intercept. So I want you guys to think of initial value as being like a synonym for y-intercept. Okay, a lot of times we have things that are math terms, and then we have the real life terms. Well, initial value is kind of like the real life term for the math term of the y-intercept. So if we take a look at this graph, you can tell in this equation, you've got your rise and your run. Okay, I see a rise of 2, and I see a run of 3. When we look in this equation, I would be able to write y equals mx plus b, replacing the m with that rise of 2 and the run of 3. And then I'm going to notice my initial value. And again, the initial value is the y-intercept. So right here, this is the y-intercept at 1. So my equation would be y equals 2/3 x plus 1, just as a quick example for this line. So not only are we going to be able to write equations where they're calling the y-intercept the initial value, but we're going to be able to look at graphs and be able to write these equations and interpret them in context. So let's take a look at our first example. It says, write each equation under its respective initial value. So just like when we looked for the y-intercept, I'm actually going to circle that and I'm going to write its synonym. So initial value really means y-intercept. And in our form, y equals mx plus b, that would be whatever number is sitting in the b position. It's the one that's not multiplying x. So initial value is the number that's not multiplying x. It's the b value. Whatever b is being added or subtracted from x. So I'm actually going to circle all the different initial values in these equations. This first equation that we see here, I just labeled that number 1. Again, it's the number that does not multiply x. So even though, like in this first tile, it's flipped around, that 3 is still the initial value because it does not have an x attached to it. You can always rewrite that equation where it says y equals negative 3x plus 3. I just flipped around the numbers and now it looks like y equals mx plus b, which again, our initial value is positive 3. So I'm just going to write that equation under the square here that's labeled 3. So that was y equals 3 minus 3x. That one's out of the way, we got it. So now let's look at the second equation. Again, just look to the number that does not have x attached to it. So that's a 2. So I know that that equation has an initial value of positive 2. So I'm going to write that under the square with positive 2 as its initial value. Okay, got that one. Now I can move on to the next one. Okay, again, I'm going to look to the number that does not have x attached to it, which is negative 2 this time. That sign, okay, that sign right there, that's attached to the number. So our initial value on that one is negative 2. So my equation should go under this square for negative 2. And then lastly, we got one more equation. Again, the number that does not have x multiplying it is positive 3. So I'm going to write that equation again under the positive 3 column. They did give us one square that did not have anything in it, and this was on purpose. They wanted to make sure you're not just putting equations in by elimination, but that you're actually thinking about what the initial value is. So let's have you give this a try on your U-Try. All right, so let's take a look at a second example. It says the graph represents the function described in words below. Write each value or equation for the linear function. So let's highlight a couple of things in our situation here. It says Josie has 1.5 cups of water in her watering can. Okay, that's important information because that tells us what she starts with. Okay, sorry about that. Okay, so I'm just going to label up here, starts with 1.5 cups. Okay, what that should tell us is a little something about y-intercept. Okay, a couple days ago we talked about how y-intercept is where something starts, and y-intercept is a synonym for initial value. Okay, so I can answer both of these right away because they're going to be the same thing. Okay, one is just worded differently than the other. So 1.5, since that's where Josie starts, that's our y-intercept. 1.5 and our initial value, which makes sense because when we look at the graph, this point right here doesn't look like it's made it quite to 2. So it would be a good guess to say that that's 0, 1.5, because the y-intercept is where it hits the y-axis. Now, I really can't read what this point is. Okay, it's got to be 28 something. Now, I'm not sure if that's 28.9 or 28.10, but we should be able to figure out what our slope or our rate of change is by reading the word problem. It's going to be in there somewhere. So it says, she fills the can before watering her plants. Her water flows into the watering can at a rate of 1 cup every 4 seconds. Rate of 1 cup every 4 seconds. That is our slope. It specifically says rate. Okay, if it says rate, that's your rate of change. So I'm going to put that in a rise over run fashion, which if we look, the water in cups is the y. So when we talk about rise over run, we should have the water over the time. And actually, I'm going to write what it actually is, and that was in seconds. Okay, so what do we have? We have 1 cup of water. 1 cup of water every 4 seconds. So our slope is 1/4. And that's the same thing as the rate of change. We know that rate of change is a synonym for slope. So now I'm ready to create my function rule. Remember, function rule just means equation. So whenever you see the phrase function rule, I want you to think y equals mx plus b. Okay, so we've really already determined what our m and what our b are. Okay, m is the rate of change or the slope, and then b is going to be the y-intercept, or also known as the initial value. So now I'm ready to create my function rule. It's going to be y equals the slope, which is 1/4, times x plus the initial value 1.5. There's our function rule. Let's have you guys give it a try in your U-Try. All right, right, so I've got one more example for you guys. It says the linear function in the graph models the height of the ground in feet of a person riding a zip line, t seconds after pushing off from the platform. How high off the ground is the platform? So let's think about this. The height is on the y-axis. So how high is the platform off of the ground? We should see where the start point is, because wherever the zipliner starts, that's how high the platform is off the ground, and then they start to descend. So really what this question is asking us to find, how high off the ground is the platform, is the initial value, otherwise known as the y-intercept. Okay, now if you can't tell where that point is, you can always look at the equation that they provide you, because the b value is going to be your y-intercept or your initial value. Now I know they used h and t, but you could have also written the same equation, y equals -5/4 x plus 100. They're just using h and t to represent x and y so that you can kind of connect that h means height and t means time. So whether you picked it out from the equation or you picked it out from the graph, the platform starts out being 100 feet off the ground. And make sure we answer with a real life answer. This is a real life question. So our real life answer, okay, let's practice phrasing this. The platform is 100 feet off the ground. That's our real life interpretation. So please, if it asks you a real life question, you need to make sure you're giving a real life answer in a complete sentence. Okay, so let's have you guys give this a shot in your U-Try. Alright, so just to recap, our learning target was to compare rates of change in initial values and interpret their meanings. We did do a lot of interpretation of meanings in context, and later on this week and next week we're going to be doing most of the comparing. So we did talk about rate of change and initial value, and we did interpret them in the context. What we did today was identify slope and rate of change from a graph or equation. That was going to be in example 1. We also could have done that in example 2 and 3 in order to make sure we distinguish the difference between the slope and the y-intercept. And then the majority of our lesson, the idea behind today's lesson, is that we identified the y-intercept, also known as the initial value. Okay, so connect that phrase, initial value, to the y-intercept. All right, if you have any questions, please let me know. You guys can go ahead and start your practice.